All right, students, and welcome to today's video. Today's video is essentially just a video to go over the lab, okay? And the lab that we're going to go over is the lab that's titled the equilibrium constant for hydrolysis of ethyl ethanoate. Okay, so this is the lab that we're going to be working with today. And just as a reminder that the actual equation that we're working for is the CH3 COO C2 H5. Okay, this is added to water, which we're going to have in excess, and that's going to be CH3 COOH, and this is going to be our acetic acid, and that's also going to go ahead and make some ethanol, C2H5OH. Okay, and this is the main equation of what we're looking for. Okay, now in this lab, what you ended up doing was you ended up having 6 different test tubes. Okay, and in these 6 different test tubes, you had one common factor. Okay, and that common factor was that you had some hydrochloric acid. Okay, so each test tube we filled up with the same amount of hydrochloric acid. Okay, we filled it with 5 milliliters of 2 molar hydrochloric acid. All right, now our second thing that we added was we added varying amounts of water. So for test tube 1, we ended up adding 5 milliliters of water. For test tube 2, we added 4 of water. Test tube 3, we added 3 of water. Test tube 4, we added even less water, 2 of water. One of water. And then the last one we added no water. To all the rest of our test tubes, we ended up adding some of our ethyl ethanoate. Okay. Okay, and we added that to correspond with the water so that we had a total of 10 milliliters in each container. Okay. What we ended up getting at the end was we ended up getting a test tube where we ended up having an equilibrium go on. Okay, so each test tube we were going to go ahead and have our water and our acid. Okay, so each test tube had our acid, and then the first one, remember, that was just water. Okay, so that's purple. First one was just water. But all the other ones, we ended up causing a reaction. Okay, So every other one ended up having a reaction, okay? So all of our test tubes ended up having a reaction, and as part of that reaction, we ended up making CH3COOH, okay? And this molecule right here, this is acetic acid, okay? And that means that since it's acetic acid, that means it's going to give off an H+, okay? And so we're going to be able to tell how much of this acetic acid we made based off of how many H pluses it made, okay? And the way that we can do that is through our titration method, okay? And what happens in a titration is that we go ahead and take some substance that's acidic. So for instance, we have a bucket of water here, and we have H pluses here, and we're going to go ahead and add to that something that's basic, okay? Usually drops at a time, okay? And what happens is that when this drop and this drop come together, they're going to end up making water, okay? And if we have an indicator in there that helps to judge the pH, we'll be able to judge when we have run out of H pluses, okay? So I gave you an indicator that indicated when it was at a pH of about 6.8, okay? So what we had was we had our initial solution, okay? And this was in a yellow tube, okay? Our initial solution was yellow, okay? And this is when it's acidic, okay? Or less than 6.8. When it turned pink, that's when it began to be basic, okay? So, when it was acidic, it was yellow. When it was basic, it ended up turning pink, okay? And what we did first was we did this for our first test tube, and our first test tube let us know how much acid we had, okay? So our first test tube tells us how much of the hydrochloric acid, and then our second test tube, we had to titrate out all of our HCl, and then the additional acid that we had from the reaction that went on, okay? So that means that we can go ahead and see how much base it required to neutralize our acetic acid, okay? So what we're going to do here now is we're going to go ahead and take a look at our data, and we're going to look for data 1, okay? And data 1 is our original test tube, and it says that we had a final reading of 10, an initial reading of 0.1, 0.9, and it has titrate, and so the titrate is going to be how much it took to use up all of the acid in test tube 1. Okay, so it took 9.1 milliliters. Okay, test tube 2, which is the one we're going to look at, that final was at 25.85. Its initial was at 10, and the final was at 15.85. Okay. So going back here, we know that test tube 1, that this amount of HCl takes 9.1 milliliters. Okay? This amount of HCl takes 9.1 milliliters. which means that this amount of HCl takes 9.1 milliliters. Okay? And that means that any extra that we added on top of that 9.1 was to cancel out the acid that we made in the reaction. Okay? So that means that this one right here ended up making some extra acid, and it ended up making 6.75 milliliters extra of that acid. Okay? And we know that because this is how much acid was in there originally, and this is how much we had, and this is the difference between these two. Okay? We will end up doing the same thing for 3, and for 3, I think we ended up having 18 as the final. For our initial, we had 0.5, and we have 17.5 as our titrate, and we're going to compare this number with this number. Okay? Our next step is that we need to not find how much NaOH, okay? Because this is how much NaOH we made. So we have NaOH that we made, and we have 6.75 milliliters of that. Okay? Well, we know that 1 mole of NaOH combines with 1 mole of acetic acid, and that's going to go ahead and make sodium acetate and water. Okay? So we know now that this one and this one come together in a 1-to-1 ratio, which means that if we find out the number of moles that is in this milliliters right here, okay, in this volume, we'll be able to figure out the moles that was in this volume, okay? And this volume, remember, is this that's right here, okay? So the moles of this in here is going to equal the moles of this that we use to cancel it out, okay? So what we'll do is we're going to go ahead and find our concentration for sodium hydroxide. And I know for certain that sodium hydroxide, we use 1.0 molar, okay? And remember that molar is moles over liter, okay? Here we have milliliters. And what we're going to do is we're going to turn that milliliters into liters to make it so that we can get rid of this liter, so that we can get our number of moles, okay? So that means that we're going to go ahead and go from here. We're going to turn it into 0.00675 liters, okay? This will cancel, which means that in total here, we used up 0.00675 moles of NaOH. Okay? And since these come in definitive proportions, we can say, if we made this many moles of NaOH, we also made this many moles of acetic acid. So that means that we can go ahead and say that we have 0.00675 moles of acetic acid. All right? Now, the last part that it wants us to solve in this section is that we are working with concentrations, okay? Whenever we work with equilibrium, we want to work in concentration. So we have to turn this into a concentration. And how we're going to do that is we're going to divide by the number of moles, or by the number of milliliters that are in our test tube. Okay? So we have to divide this by the number of milliliters. Okay? Now remember, in all of our test tubes, we ended up making it so that we had 10 milliliters total. Okay? Since we have 10 milliliters total, we can go ahead and divide this by 10 milliliters. And we have to kind of do the same thing as we did before, where we have to go ahead and convert this milliliters into liters. And 10 milliliters is going to be 0.010 liters, which means that our concentration in this vial that we use for our second sample is 0.675 molar CH3COOH. Okay. So that is how we solve the first concentration here. The next thing that it wants us to do is it wants us to solve the concentration for ethanol. Okay? So we're going to go back here, and we're going to go back to our main equation here. And I want you to notice here that this is how much acetic acid we make. This is how much ethanol we make. Therefore, if we're making a concentration of this, that's going to equal to the same concentration as this one right here. Okay? And so when that happens, we're going to also be able to take that 0.675 molar CH3COOH, and we're going to have 0.675 molar C2H5OH. Okay? Because they came together in the same ratio. So they're going to have the same concentration. The last one that we need to solve for in our equilibrium is going to be the concentration of our original stuff. Okay? And our original stuff is something that we did not measure, so they give us a little bit of help. They tell us that the density of it is 0.9. Okay? So that's going to be grams per centimeters cubed. And we used 1 milliliter, okay, in that first one. And 1 milliliter is going to equal centimeters cubed. And so if we're trying to get grams, which if we're going to find moles, we have to get grams first, we're going to multiply these two together. Okay, so 0.9 times 1, and that'll give us 0.9 grams of our ethyl acetate. Okay. Now what we'll have to do is we're going to have to divide this by the molar mass of ethyl acetate. Okay. So we're going to go ahead and, we can make our normal conversion. Remember, grams goes on the bottom, moles goes on top. 1 mole. And here, the molar mass for ethyl acetate is 88 grams. So 1 mole of ethyl acetate is going to be 88 grams. We have 0.9 grams of ethyl acetate. So here we can go ahead and solve for the moles of ethyl acetate. And that ends up being 0.01 moles of ethyl acetate. Okay? Now we also know that this is how much we put in. Okay? So we put this much in. But we know from our first image here that some of this got used up. And we know exactly how many moles of it got used up. We know that 0.00675 moles of it got used up. Okay? And we know that because that's how much of our product that we made. So we can go ahead and subtract this out, and we will be left with 0.00325 moles of our solution left. Okay? When we divide that by our concentration number, we're going to, by our milliliters of liquid, we're going to end up getting a concentration of 0.325 molar. Which means that we can go ahead and put this into our equilibrium constant. Okay. And from here, if we wanted to, we could go ahead and solve. All right. In the document, it does tell us to use water. Since water is in excess, though, it's not going to be something that's really actually useful for us in our calculations here. So at part G, I would like you to solve it, but please do not use that in your equilibrium expression, as it will end up messing with your equilibrium expression. All right. That's going to go ahead and close us out for what we need for this lesson right here. Again, when you go through, you should notice that all your equilibrium constants do end up equaling one another. And if they do deviate, please let me know so that I can go ahead and verify and see what kind of data errors that we may get going forward. Again, a data error doesn't necessarily mean that you've done anything wrong. It just signifies that there's something interesting going on in the equation. All right, I'm going to go ahead and stop this so I can publish it, and I hope that you all have a wonderful evening.